Hello students, the next topic is continuous charge distribution. So far we have discussed a discrete charge configuration, that is individual charges. In microscopic level, the charges are discrete in nature. Why we need to study about the discrete configuration of charges? Because for the mathematical simplicity, we just going for the discrete level. If we go for the application practical purpose, we should go for the continuous charge distribution. For the macroscopic level, that is, if you are taking any metal or any surface, it should be a it should have a many number of charges in it. So the continuous charge distribution is very much helpful in finding the value of those things. So according to that, the charge distributions are classified into three major types. One is linear charge distribution, and second one is surface charge distribution, and third one is the volume charge distribution. So what does mean by charge already we know. Before going to that, we need to know charge density, the concept of charge density. Charge density is nothing but charge per unit dimension. This dimension may be of length, or maybe of surface, or maybe of volume. So how many number of charges present in a given surface or given length of wire, or it may be a volume of it. So first, a linear charge distribution. Linear charge distribution is basically applicable for the case of any wires. So with a given length, a charge per unit length is known as linear charge density, and which is denoted by the letter lambda. Where lambda is equal to Q by L. Q is the number of charges present in the given surface, and L is the given length. If the element is too small, this is for the case of uniform distribution, not uniform field, uniform charge distribution. For a small element, it can be considered as a lambda, which is equal to del Q by del L. The del here we are using to represent the small element as del. The unit for linear charge density is coulomb per meter. The next charge distribution is surface charge distribution. Surface charge distribution can be represented by charge per unit surface. In the case of previous one, we have taken the length. In this case, we are taking the surface. How many number of charges are present in the given surface? So the surface charge density can be denoted by the letter sigma. The sigma can be represented by Q, capital Q by S. Here the Q stands for number of charges present in the given surface, and S denotes the surface enclosed it. So for the same process, sigma is taken as for a small element del Q by del S. Here the unit for surface charge distribution is coulomb per meter square. The next charge distribution is volume charge distribution. Volume charge distribution can be defined charge per unit volume, that is, the dimension can be taken as volume, which is denoted by the letter rho. Rho is equal to Q by V. Here the only thing is the denominator values will be changing. For the first case, it is taken as length. For the next case, it is taken as S. And the third case, it is a volume. Or for the small element, it can be represented as rho, which is equal to del Q by del V. The unit for this case is unit of surface volume charge distribution is coulomb per meter cube. So hereafter only we are using charge configuration in a continuous manner, because all the applications part will be taking place only continuous charge distribution. We cannot go with a single charge. If you are taking any metal surface, we cannot isolate a single charge in it. We are taking on the whole the part of the conductor element. So only hereafter we are using continuous charge distribution for the application purpose.